Hey guys, welcome to How It's Designed. And in this SolidWorks tutorial, we're going to do things a little bit differently. We're going to get away from breaking down design trees, and we're going to actually go over a stress analysis of a simple bracket, L-bracket part, stainless steel. As a mechanical engineer, this is very useful in running simulations, doing a little bit of FEA. So we're just going to do a quick and brief introductory tutorial to SolidWorks simulation using the SolidWorks add-in here. So why don't we just get started? We'll bring up our simulation add-in. So once we're in this tab, we're going to go to New Study. We're going to go to Static. And the first thing, we already have a material assigned, so that's the first thing you want to check. We have 304 stainless steel. Now we need to start fixing and constraining it how we want. So let's just say that this bottom side is fixed for now. And now we have to add our force. So we'll do force. We can pick a edge or a face. Let's do a face for now. And we're gonna work in English units. We'll do, let's say, 60 pounds. So we have this force going normal to that face. We can select a direction if we want it in a different direction. Up or down. But for now, let's just do normal. Let's actually do 85. Now, once we have our load and fixture applied, we can set up a mesh. So we're going to right click and go to Create Mesh. We're going to start with just a medium-sized mesh for now, so just leave that in the center. To get more accurate results, you're going to want to do a finer mesh. We'll get to that later. And we can play with the Jacobian settings. We're going to use a blended curvature based mesh. You want to have a couple nodes at least within the least thick parts of the part, so it's good that we have a couple here. Looks good for now. Let's go ahead and run it. Alright, so right now we need to make a couple adjustments on our graphs. On our chart right now, let's go to chart settings. We'll go to KSI. And right now on the von Mises, it'll give us a couple different things. Displacement, so how much it's bending from the normal, and the von Mises stress, which is the sum of the shear, normal, and all that. So we will deep dive into the von Mises and make some adjustments. Let's change our minimum value to 0, and we'll change our maximum value to the ultimate tensile strength of 304 stainless steel, our material. So we are going to go to the mechanical properties, and it looks like it is 73.2 KSI. And now we can adjust our chart to only show where things are yielding at the yield stress. So basically where things are deforming. So we're going to get an ISO clipping. We're going to set this value to our yield strength, which is 31.2 KSI. Okay, it looks like we're not getting any deformation to the part right now at the force we set, because there is no signs. There's nothing showing up here. So let's turn off let's increase this force to 200. Run it again. Still nothing. Let's increase this to, that's good, by the way. If there's no signs of yielding, then that means your part didn't fail. Let's go to 1,000. We can start to see where seeing some stresses a little bit higher. Let's go to 3,500 pounds. All right, now we're seeing a lot of forces. You see this red here, it's way up past the yield stress. So this part is definitely going to fail. We can now go here. Now you see at our yield strength, number 31 KSI, this is all the areas where it's yielding and deforming essentially. So we know that there's some concerns with this part. So it'd probably be good to actually physically test this part in real life to compare your results so that you can see how far it deforms. So that's a neat little tool you can use to visualize your stress analysis. In another video, I'll cover displacement and some other tools you can use to better run your simulations, and we'll do different examples. But for now, I just wanted to give you a quick overview. There's a lot of stuff you can do with the mesh as well. So definitely subscribe to the channel. Check out my website, howitsdesigned.com, and we'll see you next time.